In the last session, we saw exponents and powers for the 8th standard CBSE mathematics. We saw the law of exponents, and we solved a few selected problems from exercise 10.1 of the NCERT textbook. In this session, we are going to see the topic exponents and powers, the standard form of exponents, or exponential form, or it is also known as scientific notation. So this is what we are going to see in this session, and we are also going to solve a few selected problems from the exercise 10.2 of the NCERT textbook. Now let us go into the session. First of all, what is the standard form of exponents? The standard form of an exponent is exponential form, takes this form: a into 10 power b. That is a multiplication sign between a and 10, and then b is the exponent. 10 is the base, and a is called the coefficient. So it is multiplied by 10 to the raised to the power b. So this is the standard form of exponents, and it is also known as the scientific notation. Remember, a, the capital letter A stands for, is a positive real number, and a is less than 10. So whenever we express a number, a large number or a very small number, less than 1 or less than 0, a large number greater than thousands, 10,000s, and 1 million, and so on. We use this notation to express that large number in a concise form. So here, that capital letter A should be less than 10. It is a positive real number which is less than 10. Let us see some examples of standard forms of this exponential number, this standard form of large numbers or small numbers. Let us see a positive power. Positive power means large number, very large number. Here you see 4.3 into 10 power 6, which means the 4.3 is a number that is represented by the A is represented by this 4.3 into multiplied by the 10 is the base and x is the power, which is a positive power. So if 10 is raised to a positive power, it is a large number. It is a very large number. So it is equivalent to 43 followed by 5 zeros, 43 followed by 5 zeros, which means we have 4, 43, and then there are 5 zeros. There are 5 places to the right of the decimal point. We have to shift the decimal point to the right by 6 places, 6 decimal places. Thereby, we get 5 zeros in addition to that 1 decimal place already there. Coming to the negative power, for a small number, very small numbers, we use negative exponent. Negative power is equal to very small number, like a small number represented less than say 1 or a fractional number, decimal number. Now 2.1 into 10 power minus 3 is equal to 0.021. The 3, the exponent negative 3, the minus 3, represents that there should be 3 decimal places in the number. That is represented by 2.1 into 10 power minus 3. Having seen some examples here, let us go to solve. Let us solve now a few questions from exercise 10.2 of the NCERT textbook. Let us take the first question, express the following numbers in the standard form. The first subdivision itself. We have selected two questions from there. One, a very small number, and the second one is a large number. Subdivision 1, 0 point, how many zeros are there? We have to count. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 zeros. And then we have a 8, 5. Let us try to solve this first subdivision first. Solution to this problem. Count the number of decimal places. First of all, we have to count the number. To convert this in a very easy way, we just have to count the number of decimal places. That's all. Up to and including the first significant digit after 0. The one that comes after 0 is 8. So there are 12 decimal places. There are 11 zeros, 11 leading zeros. Leading zeros are those zeros that come before the significant digit. 8 here. So there are 11 zeros and a 8. So there are 12 decimal places. So we can write that in this form. Simply put 8.5. Simply take this as 8.5 because we know that this the number, the coefficient, this is called the coefficient, should be less than 10. And it should be greater than, it should be a positive number which is less than 10. So it cannot be a negative there. It should be less than 10. So 8.5 is, which is less than 10, into the negative power of 12. Because there are 12 decimal places, we should put 10 raised to the power minus 12. Since the given number is less than 1, we use the negative exponent. Very small numbers. Hope you understood this. Let us move on to the next, fifth subdivision. The fifth subdivision is a very large number. You see the number of zeros there. Count the number of digits after 3. Only the first, or rather the most significant digit is 3 there. And the least significant digit on the other side, that the right hand side, is 0. So the least significant digit we take 3. After 3, how many zeros? How many digits are there? Count the number of digits, 1, 8, 6, and followed by the trailing zeros. Including the trailing zeros, how many digits are there? There are 10. There are 7 zeros and 3 digits, 186. Look at this, 186 followed by 1, 2, 3, 4, 5, 6, 7. So 7 plus 3 is 10. So in this case, we have 10 digits after the 3. We can write this in the standard form as 3 point. Now we have to place the decimal point there. 3.186. We know that the number is greater than 1. So we have to put a positive exponent. Use a positive exponent. The 10 digits are there. So 10 number of digits. So 10 power 10. The base is always 10. In any standard form, the base is 10 and the exponent is determined by the number of places, the number of digits after the, in this case, it is after the most significant digit, that is the left hand side. How many places are there? There are 10 places. Therefore, we put 10 power 10. I hope we understood this particular problem. This is a typical example of standard form. Now let us do the reverse process. If you are given a number in the standard form, how can you express this in the usual form? How to express a number in the usual form? That is the normal way of writing a number, isn't it? Let us go to the second question. The second question, express the following numbers in the usual form. That means, let us take the first subdivision itself. The first subdivision, 3.02 into 10 power minus 6. Here the negative exponent is there. So it represents a small number which is less than 1. So we will now take this exponent as negative 6 minus 6. Must be 6 decimal places before the decimal point, including the 3. So the decimal point has to be shifted to the left. How many places? 6 places. So 6 decimal places, including the 3. So we have to add 5 zeros before the 3 to get the required number in the usual form. As how many zeros have we added now? 0.00050 zeros and the 302. This is written as 302 without the decimal point, because the decimal point has been shifted to the left by 6 places. So 6 places by adding 5 zeros before 3 to get the required number in the usual form as 0.0000302. 0.0000302. And that's the required answer for the first subdivision. Now let us do the sixth subdivision, one example for a very large number. 10 power 6 is there. It is a positive exponent. So we conclude that the number is greater than 1. It's a large number. Since a positive number for a large numbers, the decimal point is shifted to the right, or the decimal point is removed. Here the decimal point is removed because there is no longer a decimal number. It's after multiplying by 10 power 6. Now we see that here 10 power 6, 10 is the base and 6 is the exponent. There should be 6 places to the right of the decimal point. Let us now fix that. Already there are 1, 2, 3, 4, 5 places to the right of the decimal point. Just we have to add one more 0. That's all. So what we do is just we add, already there are 5 digits to the right of the decimal point. So we must add only 1 0 to get the number in the usual form, because there should be 6 into 10 power 6. So we just add one more 0 to get 361490, which is 36 lakhs 14,920 in the full form. See, we transform this number 3.61492. Keep the digits intact. Do not tamper with the digits. The digits have not be undergoing any change. The same digits appear here also. See, 361492. Just 1 0 is added. So total number of places in this is the 6, because it is multiplied by 10 power 6, a million, 1 million. And 1 million, you have 6 decimal places. There should be 6 places to the right. So 1, 2, 3, 4, 5, 6. So I hope it is clear. You have any doubt in this? You must check on this. You may go through this once again. This is required answer 361490. Now we have solved a few questions in exercise 10.2. The rest of the exercise you can complete, and now you can solve the remaining questions in exercise 10.2 on your own. If you have any difficulty in solving any question, raise your doubts in the comment box. Thank you and best wishes from Beta Online Learning.